can take a look at the next example here. So this is example number 3. We have a football kicker who's trying to make a 30-yard field goal, and the ball must travel over the goalposts, which are 10 feet high, as well, and 30 feet away or 30 yards away. So that's kind of what we're looking at, as well as a blocker who can reach 9 feet high and is only 5 yards away from the kicked ball. So we need to create an equation which would model the lowest trajectory that the ball would travel. Now, what that means is we have to try to figure out what kind of graph is going to look like this. Boom, there we go. There's our field goal. Okay, there's our field goal where it gets kicked from the point where we're going to call it 0, 0. It has to get over our blocker who's 9 feet high right here. Okay, and he's only 5 yards away. And it has to get over the goalposts, which are 10 feet high, and they're 30 yards away. So we have to come up with what is our graph going to look like. Okay. Now, what we're going to do here is we're going to put in some points and we're going to create an equation which models that. So I'm going to bring up Desmos. Okay, and you'll notice here's my previous one. Let's bring in a new blank graph. Okay, and I'm going to make a table of values. Okay, first point that I know is that I'm going to start at 0. So when the ball is kicked, it has not traveled anything vertically, nor has it traveled horizontally. So it's going to be 0 and 0. Okay, and sorry, I forgot to start one other thing here. I should really label what my x and y are. I'm going to do that right away. Okay, so remember that x is going to be equal, that's going to be across. Okay, so x is going to be how far the ball has traveled. Okay, so how far horizontally the ball travels. And this is going to be in yards. That's what we're given. Okay, we're given yards. And y is going to be how high, how high the ball is at a certain time, and this is in feet. Okay, we have two different measurements, so we're using yards and feet, and that's totally fine. We can gladly do that as long as we remember which is which. I'm gonna use purple for this because I like purple. All right, the first thing we do is come up with our equation. We need to use Desmos for that. So let's plug in a couple points which match. 0, 0, right there. Okay, there the ball is. We know that it has to get over a 9-foot tall guy who is 5 yards away and 9 feet tall, right there. The ball's got to travel over that guy right there. That's a really tall guy. Okay, so it's got to get over that guy right there. And when it is 30 yards away, it has to reach over a 10-foot pole. So it has to get over that post right there. All right, so those are 3 points that we have. We don't know anything else in between. We don't know where it's going to land. We will get that all later on. But those are the points that we know where it's kicked from. We know what it has to go over firstly, and then what it has to go over secondly. Now we're going to type in our regression. So remember, y1, a little twiddle, is equal to a x1 squared plus b x1. You'll notice things are always kind of popping up, plus c. Now that one didn't change because c happens to be exactly the same. It's 0, so that one doesn't really matter. But you'll notice that this is going to go over that. It's going to reach a vertex there, and it's going to go over the pole here, and it's going to land. Okay, this is what is kind of creating our equation. Now, you have not actually created the equation yet. You've figured out what the A, B, and C are. You still need to type in our equation. So our equation is y is equal to negative 0.059x squared. Okay, I'm rounding two decimal places there, plus 2.09x plus 0. There it is. And look, it's pretty close. Okay, this is what we're going to use. Okay, we're going to end up using this to come up with all our values, but this is our equation that we're going to put into our graph later on. I'm just going to get rid of that right now because we're going to use the one that Desmos gave us. This is what we're going to put in as our final answer later on. Okay, so, and I'm actually going to copy and paste it here. So for A, we want to come up with an equation. It is this one right here. Okay, and now it looks a little bit messy because we're transferring between two different things, so I'm just going to create a little better there. There we go. Y is equal to negative 0.059x squared plus 2.09x plus 0. That's the equation that's going to represent how the lowest trajectory the ball could travel. It could go higher, okay, because it could go, that's just the way it is, but we're trying to find what is the lowest trajectory that we need to do. Now in the next video, we're going to look at the next couple of answers as well, now that we have our equation that we can use.